Bismillahirrahmanirrahim. Assalamu alaikum students. Welcome to Air Foundation School System. This is class 10th physics. Today we are going to start our second chapter, that is kinematics. So what is kinematics? Kinematics is the branch of mechanics. In our ninth physics, in unit number 1, we discuss about different branches of physics. The first branch is the mechanics, and in our first chapter we defined mechanics as the branch of physics that deals with the motion of objects, their causes and their effects is called mechanics. So mechanics has two different branches. So these are kinematics, this is our unit number 2, and the other branch is dynamics, that is our unit number 3. So in kinematics deals with the motion of objects without discussing their causes. In kinematics, we discuss only about the motion of objects. We not discuss about their causes and their effects. So in dynamics, we discussed about the motion of objects and their causes and their effects. So on the basis of motion and its effects and causes, we divide mechanics into two branches. Kinematics only deal with the motion of objects, and dynamics deal with the motion of objects and their causes. So our first topic is rest and motion. What is the difference between rest and motion? A body is said to be in rest if it does not change its position with respect to its surrounding. In order to define rest and motion, we must have a reference point, we must have surroundings. So in case of rest, a body is in rest if it does not changes its position with respect to its surrounding, then this body is said to be in rest. Similarly, a motion can be defined as a body is said to be in motion if it changes its position with respect to its surrounding. So here surrounding is the reference point. So in order to define rest and motion, we must have a reference point or some surrounding. So rest and motion are relative, they are not absolute. For example, a passenger sitting in a moving car is in rest and in motion as well. The person is in rest with respect to things inside the bus, and the same person is in motion with respect to the bus, with respect to the things outside the bus. So this example proves that rest and motion are relative, they are not absolute. Similarly, the people on earth, for example, a person sitting on earth is in rest according to the objects on the earth. Similarly, the objects moving on earth can be viewed from moon or can be viewed from sun, and these objects are in motion as earth is revolving around the sun. So all the objects on the earth are in continuously motion with respect to some other reference point elsewhere. So rest and motion are not absolute, they are relative. Now next, move towards the types of motion. There are three main types of motion here we discussed. The first one is the translatory motion, the second one is the rotatory motion, and the third one is the vibratory motion. So these are the three basic types of motion. Translatory motion can be defined as, in translational motion, a body moves along a line without any rotation. The line may be straight or curved. So in translatory motion, there is no rotation, the body move along a line without any rotation. The line may be straight or curved. Translatory motion has further three types. For example, the linear motion, circular motion, and the random motion. Linear motion is only straight line motion of an object is called linear motion. For example, a car moving on a level road in straight line. For example, an objects falling down. For example, an aeroplane flying air in straight line. So these all are the examples of linear motion. There are many examples in our daily life which can be expressed in terms of linear motion. The next one type of the translatory motion is the circular motion. The circular motion is the motion of an object in a circular path. For example, a toy train moving in a circular path. a stone revolving in a circular path. So these are the examples of circular motion. The third one is the random motion. The disordered or irregular motion of an object is called random motion. For example, the motion of insects, the motion of dust particles, the motion of birds in air. Similarly, there are many examples of random motion in our daily life. The next type of motion is the rotatory motion. The rotatory motion can be defined as the spinning motion of an object about its axis. Circular and rotatory motion are two different types of motion. In rotatory motion, the objects move in a circular path but about a fixed axis. Objects move in a circle of constant radii in case of rotatory motion, and in case of circular motion, the objects doesn't move in a object move in a circle of variable radii. So rotatory motion is the spinning motion of an object about its axis. For example, the motion of wheel, the motion of steering wheel, the motion of fan about its axis. So these are the examples of rotatory motion, not circular. The next one is the vibratory motion. Vibratory motion means to and fro motion of an object about mean position. So back and forth motion, to and fro motion of an object about mean position is called vibratory motion. For example, motion of pendulum of clock, motion of seesaw. So these are the examples of vibratory motion. And our next topic is scalars and vectors. These are two quantities in physics we are used. Those are scalars and vectors. Scalar quantities are described completely by its magnitude only. In order to describe scalar quantities completely, we require only the magnitude of the quantity. For example, mass, there is no direction of mass. For example, length, there is no direction of length. For example, time, speed, volume, work, energy, density, pressure, all these quantities are completely described by their magnitude only, and they have no direction. Vector quantities are the quantities which are described by magnitude and direction. In order to describe vector quantities, we must have magnitude plus direction. For example, velocity, for example, displacement, for example, force, momentum, torque, weight, etc. So these are the quantities which require magnitude as well as direction for their description. So those quantities which are only described by magnitude are scalars, and those quantities which are described by magnitude as well as direction are called vectors. So next, vector representation. Vector can be represented by two ways: graphically or symbolically or numerically. Graphically, a vector is described by line segment with an arrowhead, where the length of the line represents the magnitude of the vector and arrowhead give its direction. In this example here, AB is the magnitude of this velocity. AB is the magnitude of this velocity, and V is arrowhead represents the direction of the velocity. Numerically, a vector is represented by bold letters or by putting bar or arrow over their samples. For example, F is the 4. If we use bold F, then it is vector. If we write bold V, then it is vector. And similarly, we putting arrow over for F and over V, we can represent numerically a vector. So this is our today's lecture. If you have any problem regarding the lecture, you can ask me in comment section. Thank you so much. Allah Hafiz.